years, I've had the opportunity to work with Trout Unlimited, both with their professional organization and with their volunteer chapter locally, the Ridge and Valley chapter. So they have really elevated our work, and I know you guys are in for a real treat tonight. If you are local, please come fish Lopakon Creek. Hook up with those Ridge and Valley chapter guys. They're great fishermen. They know all the sweet spots in the Lopak, and they'll be happy to show you around, I'm sure. You can also come out and work with me and the guys at the Ridge and Valley chapter on our next stream cleanup, which is going to be scheduled on November 14th. So keep an eye on the Lopakon Creek Initiative Facebook page for that. And again, I'll be back in a few minutes to get us started on our speakers. But for now, I want to introduce our partner, Kyle Richter from the Musconetcong Watershed Association.
Thank you, Juniper. I'm Kyle Richter, the Watershed Programs Coordinator at the Musconetcong Watershed Association. We are a nonprofit dedicated to protecting and improving the Musconetcong River and its surrounding watershed, including its natural and cultural resources. The Musconetcong River flows from Lake Apatcong down to the Delaware. It is actually New Jersey's largest tributary to the Delaware River. The Musconetcong Watershed Association has a variety of programs that we use to help protect the river. We have education and outreach programs. We have a citizen science water quality monitoring program called the River Watchers. And we take part in many restoration activities throughout the watershed that help provide critical habitat for species such as trout. And if you'd like to learn more about the Musconetcong watershed, you can visit us at www.musconetcong.org, where you can find out about some of the fun events we have coming up, including our Clean As You Can campaign, which is aimed at getting watershed residents out cleaning up the Musconetcong. And I would like to pass it off to Lori Howard from the Passaic River Coalition.
Thank you, Kyle. Well, good evening. We're delighted for this evening's presentation, as we know that tonight's audience is especially dedicated to keeping our rivers and streams clean for those fish. Passaic River Coalition is a regional volunteer nonprofit that advocates for the entire Passaic River watershed. Our mission is to improve water quality, protect our water supplies, promote river restoration, reduce flood damages, and educate the public about our waters, precious rivers and streams, and encourage public accessibility and usage. Additionally, we preserve environmentally important lands in our watershed. Our land trust properties generally feed into the tributaries of the Passaic and include acreage in the highlands as well as the lower Passaic. Throughout the year, we do in fact get many calls about fishing, as some have the notion that we own the Passaic River, and we do answer all the calls. However, we do rely on the public and our volunteers to let us know what is happening out in our rivers and streams so that we can address problems that need our attention. So do reach out to us. Our website is www.passaicriver.org, and do visit us at our historical landmark headquarters at Willow Hall in Morristown. And now to Henry Geider.
Hello, everyone. My name is Henry Geider. I'm the policy director of the New Jersey League of Conservation Voters. New Jersey LCV represents Democratic, Republican, and independent voters who are committed to strong environmental policies that safeguard the health of our communities, the beauty of our state, and the strength of our economy. We thank our partners for the opportunity to talk today and are very happy to be a co-sponsor of this great virtual event. We know the importance of clean water for our economy, our ecosystems, and ultimately our recreation throughout the state. One major threat to the well-being of our waterways and ecosystems is unmanaged stormwater. It is a major factor that leads to diminished water quality that we see in nearly 95% of New Jersey's waterways, and one of the prime culprits that cause the Hartle algal blooms that we see pop up throughout the state each year. We work with our partners to educate municipalities and local elected officials, community organizations, and other stakeholders on the importance of managing our stormwater through our Flood Defense Coalition. You can find more information about our efforts at flooddefensenewjersey.org. That's flooddefensenj.org on how you can be a strong advocate for cleaning up our stormwater by making smart investments in the essential infrastructures that capture stormwater like a sponge and prevents all of the pollutants it picks up from entering the very waterways that nourish our trout community. So thank you everyone very much.
Thank you so much, Henry. That was great. George is co-owner of Shannon's Fly and Tackle Shop in Califon, New Jersey. After graduating from the U.S. Merchant Marine Academy with a degree in marine engineering, George worked in the ship design field for over 40 years. He received a master's degree in management science from Stevens Institute of Technology. I promise I can talk and read. A lifelong New Jersey resident, he was a trustee of the Great Swamp Watershed Association for several years, where he chaired the Land Use Committee. He is a member, trustee, and past president of the New Jersey Highlands Coalition, where he represents the Alliance for Historic Hamlets, an advocacy group that he co-chairs in Hunterdon County. He is a trustee of the Raritan Headwaters Association and the Morris County Trust for Historic Preservation. He has recently joined the board of the Tewksbury Historical Society. George has served on the Tewksbury Township Scenic Roads and Bridges Commission for several years. So like I said, busy guy, and I know we're in for a treat. So welcome, George.
Thank you, Juniper, and welcome to everyone. My interest is in this webinar, specifically one of crass commercialism and self-promotion. As a co-owner of Shannon's Fly and Tackle, we have a direct economic interest in the abundance and cleanliness of waters in which our customers hope to fish. So New Jersey's fisheries in general are broken into two main components: saltwater and freshwater. The saltwater component has long enjoyed an international reputation and a high respect for the quality and diversity of its commercial and recreational angling opportunities. Just last week, Governor Murphy credited New Jersey's saltwater fisheries with contributing $2.5 billion to the state's economy. Well, I can tell you that fly fishing and freshwater fishing in general comes nowhere near that. But my purpose tonight is to give you some reasons to consider why New Jersey's freshwater fisheries are also worth your attention by posing two primary questions. One, is trout fishing in New Jersey an oxymoron? And two, what makes trout unique among the other freshwater fish? The first slide here shows, in essence, the composition of New Jersey's freshwater fishery. This comes from the New Jersey Division of Fish and Wildlife, illustrating the 32 freshwater fishes of particular interest to anglers in New Jersey. If you look at the left page at the top, you'll see a row of 3 and then another row of 2 fish. The top 3 are all trout, and they are of our particular interest tonight. The next 2 are also trout or trout related, but they reside in still deep lakes and reservoirs. And this evening, our attention is placed on the flowing streams where trout like to live. Those first 2 rows, the 3 trout and the lake trout and the landlocked salmon, are what are termed cold water fish. Those fish depend on the availability of water at temperatures that generally does not exceed 70 degrees, even in a high summer. That's difficult to find. New Jersey has water like that in more locations than you might imagine. Abundance of clean, cold water in the northwest part of New Jersey is the explanation for what I and my partners believe to be a fairly robust and sustainable trout fishery. So what kind of trout are present in New Jersey streams? In the last illustration, we showed an eastern brook trout, which is the only one of the 3 that's native to our state. There's also a rainbow trout in our streams. That's an introduced species. It was originally native to the Western US. And we also have brown trout, introduced to New Jersey, native to Europe. And it's worth pointing out that in 2018, the state adopted special regulations to establish management zones for eastern brook trout that, among other things, require any angler who who lands an eastern brook trout to immediately return it to the water. So that is a catch and release fishery. This is a photo of a young eastern brook trout caught in Hunterdon County 2 or 3 years ago from a very small stream, small enough to jump or rock hop across, probably about as wide as the fishing rod was long. I consider this fish to be a success story, emblematic of New Jersey's environmental and land use initiatives over the last 50 years. Without them, I believe this fish would be extirpated from the state, as it has been in much of its original range. It's been present in New Jersey since the last glacier retreated about 12,000 years ago. These fish grow in proportion to the size of the stream. So although the fish in the photo demonstrates dark vertical banding along its length, which indicates a very young fish, by the time this fish is 3 or 4 years old at full maturity, it probably won't be much bigger than that. Sometimes that is not exciting to people who like to catch trout big enough to hang over the mantle. But to me, the fact that New Jersey still has several self-sustaining populations of eastern brook trout in several locations is a miracle. Next, we had a rainbow trout. This rainbow trout here was landed a few years ago in the south branch of the Raritan River by a couple of friends of mine. In 2013, the New Jersey State Fishery Hatchery experienced an infection of furunculosis, which eventually required the hatchery to abandon all but rainbow trout in its fish farming efforts. So where up until 2013, New Jersey streams could be stocked by state raised fish of rainbow, brook, or brown trout varieties, today the hatchery is concentrating exclusively on a highly disease-resistant strain of rainbow trout. It was a fairly tragic situation at the hatchery in 2014 when a 205,000 stocking size brook trout had to be humanely euthanized. Back to the rainbow trout, it was native or still is native to streams and lakes in the West, particularly west of the Rocky Mountains, introduced to eastern states, including our own, beginning in about 1875. Last, we have the brown trout, which is a European import brought to this country from Germany in about 1883. It outcompetes brook trout for both food and habitat, and is one reason, not just pollution and the elimination of suitable habitat for brook trout, but the fact that the brown trout is a higher tier predator and chases brook trout as high up in the watershed as it can until there's just not enough water left for brown trout to grow big, and the relatively small brook trout can survive on their own. As I mentioned, the farm raised or hatchery raised fish in New Jersey are all rainbow trout, and this is a recent summary of the output from the Peak West hatchery. Roughly 631,000 rainbow trout were raised and introduced into New Jersey trout waters in two primary evolutions, the first being spring stocking, which is the classic opening day in the springtime. The fall stocking is supplemental in much fewer numbers, and there are also a couple of places in the winter where the trout are put in lakes. But for the most part, the spring stocking is the time when anglers celebrate. However, it's confusing to some people to understand that the trout season is open year round, except for the 2 weeks before spring stocking. So in earlier times, there were no fish stocked during the time from the spring until, say, the end of October. Now the streams are open. Our shop is open every day but Christmas, and there's almost always somebody out fishing, whether it's winter or summer or windy or cold. So we have a wide open season in that sense. Where can trout be found in New Jersey? A good question. The trout are present in 27,000 miles of higher gradient, meaning steeper streams having cool, well-oxygenated water. This includes self-sustaining populations, my favorite miracle wild trout, in almost 1,000 miles, located in the upper Delaware, upper Raritan, and Pequannock watershed. This corresponds roughly to northwest New Jersey's highlands and ridge and valley geophysical provinces with small, high gradient, steep streams and cool, well-oxygenated water. The upper northwest corner of the state, where you can see a red and a blue in greater intensity, is the highest density of trout streams in the state. And that corresponds to mountains, basically, where the drainage off of steeper slopes moves the water quickly and enables better oxygenation. The source water is frequently cold groundwater that's seeping in through springs. The question is, what kind of competition would a prospective trout angler have in New Jersey? As a total of people fishing for all species, according to this study that was done by the US Census Bureau in 2011, which is the latest available, there were some 238,000 anglers who fished in freshwater streams, lakes, and ponds. Of most interest to us is, of that number, how many were really pursuing trout. Of the 238,000, using some more recent data, we can see that there are approximately 92,000 anglers who bought trout stamps in New Jersey in 2019. And the trout stamp is something that is a pretty good way to track the interest in angling for trout. If you're doing it legally, you need to have a New Jersey fishing license with a trout stamp added to it if you're going after trout. So how many people fish for trout in New Jersey, and what is the trend? We looked at numbers between 2011 and 2019. Resident fishing license sales, which are sold to New Jersey residents with New Jersey addresses, is down somewhat, 13%. Resident trout stamps down not quite as much. But what is remarkable, and I think worth looking at from the marketing point of view, is that during that same period of time, non-resident fishing license sales went up 30% and trout stamps went up 51%, which, when you look at the states where most of these out-of-state license and stamps have been purchased, it is, in my experience anyway, it's been Pennsylvania and New York, which, if you believe the literature, are the places where fly fishing for trout was invented before the flood. So what this is telling me is that the people who live in an area of great historic significance are looking across the border, looking across the Delaware River, the Hudson River, making the trip into New Jersey and coming back again, and I believe finding some satisfactory fishing experiences in the process. All right, what do you need to catch trout? Trout fishing can be done with the bare bones minimum. You can have a rod and a reel and use worms, or you can use artificial lures or flies. The rod and the reel that with a tub of night crawlers might set you back $30, or you could also use the grandfather's heirloom split bamboo fly reel and a fly rod and an English fly reel. That would be something might be able to get a good used car for the same money. So the tackle is really not an issue. There's nothing complicated about it. It weighs, in general, a full rig less than, I would say, about 8 ounces. You can cast it all day on New Jersey streams without getting too fatigued. So you need the basic equipment, and then you need, as I said before, a fishing license with a trout stamp if you're a New Jersey resident between the ages of 16 and 70 years. Before 16 and after 70, you get a free ride. All right, what regulations apply to trout fishing? The New Jersey Fish Code is a New Jersey statute, comes from a New Jersey statute that establishes a Fish and Game Commission who determine when and by what means, at which locations, what numbers and what sizes freshwater fish can be pursued, caught, killed, or possessed. These same rules include special regulations for 41 designated wild trout streams in New Jersey. And again, I think that's quite an amazing thing to think about in the most densely populated state in the Union. And who is it that manages the trout fishing program in New Jersey? The New Jersey Division of Fish and Wildlife Bureau of Freshwater Fisheries is responsible. Another remarkable aspect is the fact that they are funded entirely by New Jersey sportsmen through the sale of fishing licenses, stamps, and permits, as well as a federal excise tax on the sale of fishing tackle. In 2017, for example, the Bureau of Freshwater Fisheries received allocations from license sales of $1 million for fisheries research and management, $2.5 million for hatchery operations.
Great, thank you so much. And thank you, George. That was an excellent introduction. I know that Keith's presentation is going to be super informative. I want to read you his bio as well. I want to introduce you to our keynote speaker tonight, Mr. Keith Fritchie. Keith Fritchie is he joined Trout Unlimited as the New Jersey Upper Delaware Restoration Coordinator in December 2019 and currently works from his hometown of Dingman's Ferry, Pennsylvania. His background is in aquatic ecology and fisheries science. He is currently a PhD candidate at Dartmouth College and his research focuses on the importance of groundwater in supporting wild brook trout populations. His work in New Jersey includes restoring the wild trout fishery of Lopatcon Creek, conservation planning in the Flat Brook watershed, and creating interactive online maps of water-based recreational activities in all major Delaware tributaries north of the Musconetcong. And I will add that I have had the pleasure of working personally with Keith since he joined Trout Unlimited. And like I said earlier, he has been a tremendous resource and has genuinely elevated the work that we do around our largest issue, which is the temperature that we need to maintain our trout population. So without further ado, I would like to introduce Keith Fritchie.
Thank you very much, Juniper, and for the Highlands Coalition for inviting me out today, and for all of you who are taking some time out of your Tuesday night to learn a little bit more about trout and water quality in New Jersey. But I would say, you know, I grew up in Pike County, Pennsylvania, just over the border. I grew up fishing the Flat Brook. I was born in Newton. So it's really great to be back in New Jersey and to learn about some of these issues that are facing our wild and stocked trout fisheries, and also try to do something about it. So I'm going to share with you some of my knowledge about wild and stocked trout fisheries in New Jersey and the relationship with water quality. But I just want to say that I'm also learning a bunch from our partners, different watershed organizations, different angler groups, et cetera. So this is definitely I'm a scientist, and science is a continual learning process. So I'm happy to be interacting with a lot of you folks, now and into the future. So I'm just going to get my presentation going here. And also shout out to John, who took this photo. I think I saw you on the presentation at least before. This is one of our wild brook trout of New Jersey. It's a beautiful, pretty fat fish. So yeah, today we're going to talk about trout and water quality. So just to give you a background, if you're not sure about what Trout Unlimited is, we're a national nonprofit group that was founded in 1959. And the mission of Trout Unlimited is to conserve, protect, and restore North America's cold water fisheries and their watersheds. So we take this general conservation approach of protecting high quality habitat, reconnecting fish and water through barrier removals, restoring degraded habitat, restoring water quality, and then sustaining these sorts of efforts through education and outreach programs. So in New Jersey, we have kind of Trout Unlimited national staff members. That includes myself, I'm a restoration coordinator for the Upper Delaware region of New Jersey. We also have a policy director, Jen Orr Green, who works across the Mid-Atlantic. But probably the best resources that Trout Unlimited has in the state of New Jersey are its grassroots chapters. So TU has 10 different chapters in the state of New Jersey, including Ridge and Valley, kind of that Juniper mentioned around Lopat, and northern New Jersey up in the kind of Flatbrook and Pollenskill and Wallkill watersheds, but many others. There's 3,000 grassroots chapter members in the state, and they're kind of organized under a state council. And these folks are, the anglers to really talk to learn about trout in the state of New Jersey, and they're also doing a bunch of great conservation work as well. So I just wanted to shout them out. So I know that there's probably a bunch of different types of people on the call tonight. There might be trout anglers who are wanting to learn a little bit more about water quality, and there might be some water quality folks, and that's kind of your focus, and you want to learn a little bit about trout fishing. And so if you take one thing away from my presentation, I just kind of want to talk about how I think there's this positive feedback loop between water quality and trout. So, most of our presentation tonight, we'll be talking about how water quality and improvements to water quality can positively impact our trout populations and our trout fisheries, both wild and stocked. But what George is really alluding to, and what I want to emphasize, is that I think having strong trout populations and strong trout fisheries in the state of New Jersey can really incentivize improving our water quality as well. And so I think that's through things like fostering stewardship. So I know that a lot of scientists in my field kind of cut their teeth on fishing, and so having that first connection to a fish, whether it's a wild fish or a stocked fish, you really start to learn and appreciate the stream ecosystem, and you want to do more about it. So we can foster stewardship through fishing. We can also protect streams because of trout populations. So in New Jersey and many other states, if there are trout populations within a stream, often those streams can be protected at higher levels than those streams that don't have trout. As we'll talk about in this presentation, we can often use trout as indicator species. So, especially with temperature, which we'll talk about mostly today, if we have decline in trout populations, that might signal a change in water quality that we can address as quickly as possible, that if we didn't have anglers out there fishing for trout, we may not have noticed as quickly. And finally, I think that good trout populations and good trout fishing do bring funding into the water quality protection and restoration arena. And that's both through license sales, which George had talked about earlier, but also things like the Dingle Johnson Act. So this is basically an act that put small taxes on fishing equipment and motorboat gas. And those income from that tax actually gets allocated across all states, kind of according to how many people are actually fishing in those states. So I believe New Jersey last year got about $3.5 million in funding that goes directly back into kind of the research, management, and education surrounding sport fishing, including trout. And then finally, as I mentioned, we have our grassroots chapters who are, contributing countless hours, volunteer hours, as well as countless dollars into stream restoration projects each year. The ultimate goal of those restoration projects, to them are to benefit trout fishing, but almost always along the way, what those projects really do is improve our water quality. So it's kind of, again, the take-home message, I think, of my presentation. If you need to leave now, you can, but hopefully you'll stick around. So as Juniper mentioned, I am doing my PhD research up in Northern New Hampshire, where I focus on brook trout. And so I'm just going to play this video just for a few minutes of some of the different brook trout that we see up in that area. And you'll notice that these are definitely different looking fish than some of the ones that George was showing. There are different, conditions for fish in the northern sections of the brook trout range than there are in New Jersey. So I really like wild trout, and I'm really hoping to restore and maintain wild trout populations in New Jersey. They might not get this big down here because of different reasons, but really this video I think kind of emphasizes what I think is really cool about trout, and that's just their behavior, their colors. It's a really attractive fish. And I think you can tell why anglers might really like them. So today, what I'll mostly be talking about is wild trout. It's kind of my role at TU is to think about how we can restore wild trout populations. But we'll talk a little bit about stocked trout fisheries as well. And in terms of the relationship between different water quality variables and trout, essentially you can imagine that they're one and the same, whether you're a brook trout, a rainbow trout, or a brown trout. Things do vary a little bit. Brook trout are probably most sensitive, but with what we'll be talking about today, if I just say trout, you can kind of just think of the species right now as interchangeable, although they definitely aren't. So what Zach had asked me to maybe address today is what trout can tell us about water quality. And I think really to get to that, to answering that question, we need to start out with how water quality actually impacts fish. So I just want to walk through a couple of slides that kind of explain my thought process on that. So first, when we have impacts to water quality, we need to have some kind of disturbance to our stream ecosystem. So that disturbance might be things like urbanization. Like see the top photo, that might be kind of cutting down riparian areas or stormwater runoff, non-point pollution, or it could be things like dam construction. And so different types of disturbance can then elicit some kind of water quality response. So in the top photo, you can see a lot of fine sediment that's getting stirred up in the bottom. There's probably a lot of erosion and probably an unnatural amount of erosion upstream that's kind of increasing fine sediment loads in that stream. So it's one water quality degradation that we think about, especially in relationship to trout. We might have increases in nutrient, so say nitrogen and phosphorus from stormwater runoff or agricultural runoff, and that can do things like increase algae, like you see in the middle photo, or we might have warming of stream temps for a bunch of different reasons, stream temperatures for different reasons. So eventually these water quality responses elicit some kind of biological response. And in the fish community, that can be sort of a direct biological response. So you can imagine that increases in temperature directly impact the biology and the performance of trout. You might think about the same thing with pH or conductivity or certain chemicals. Whereas things like nutrients and sediment might actually be impacting our fish communities kind of through the very complex food webs that live in our streams. So through things like algae or other small plants in our streams, and through things like these macroinvertebrates, which really form the basis of the fish food web. So this is kind of how disturbances impact water quality, which elicit a biological response. And so now we want to know, how do we go the other way around? How can we have a fish actually tell us something about water quality? And so to do that, many scientists in the state of New Jersey and all across the world use these different things called indexes or indices of biological integrity. So biologists go out and sample different fish populations or different macroinvertebrate populations, those bugs that live in the streams. And what they're trying to do is, by knowing who shows up in that stream, so which kind of individuals from this potential species pool, can we start making predictions about what are the water quality conditions in that stream? Are they generally high or generally low? And therefore, what's the general stream condition? Is it a disturbed and stressed stream, maybe because of agriculture or urban development? Or is it a pretty low disturbance stream that has high forest cover? So to actually create these indices of biological integrity, scientists have to do a lot of work relating many different fish species to different conditions and comparing them to reference conditions, which are sometimes hard to find in New Jersey. But essentially, I'll just give you kind of an example of what comes out of this. If we find things, just like brown bullhead with nothing else, that index might indicate that we're in a lower water quality condition, indicating that stream is probably in lower condition, higher disturbance. When we find things like white sucker and creek chub, that might indicate that we're in this middle ground area. And then when we find things like brook trout, those often indicate we're in high quality streams, really good water quality, as George had mentioned. And so there really are these indices that are calculated, and brook trout make up a really important component of them. So to some extent, brook trout can tell us about water quality, and they can tell us in general that water quality conditions are high if they're present. So if you want to learn more about those sorts of approaches, those indices of biological integrity, I really highly recommend that you go to the New Jersey's Bureau of Freshwater and Biological Monitoring website, where they really do a great job of explaining where these indices are coming from, how are they used, and can find data across the state of New Jersey to see if your local stream, is impaired based on these different indicators, biological indicators of water quality. But for the rest of the talk, what I want to do is maybe move away from those indices and think specifically about how trout are responding to water quality, and ultimately what that means, or what we can learn about water quality from those trout. So when we focus on just one species, we can start knowing more concrete relationships with specific changes in water quality. So here we know through a lot of available research that brook trout generally don't do as well when we have fine sediment loads. So fine sediments can kind of clog and choke the gravels where brook trout food lives, so these macroinvertebrates. And so by decreases in our macroinvertebrate populations through sedimentation, we could have decreases in the abundance or the biomass of trout. Trout also need to lay their eggs in the gravel bed of the stream. And so when we have high sediment loads, fine sediments especially, that sediment can actually coat these eggs and actually reduce oxygen getting to those eggs and actually reduce reproduction overall. So we do know to some extent that sediment is not good in general for brook trout. However, brook trout also have many different ways of getting around these conditions. So we know that brook trout now are highly mobile relative to many other fish species. So they can move into areas that don't have sediment problems to feed, and potentially move back into those areas with sediment problems if they have good cover. So deeper pools or slower moving pools where sediment often accumulates, but they can escape predators there. And we also know that groundwater is probably the most important aspect of habitat when it comes to successful brook trout spawning. So if groundwater exists in a stream bed, it can actually provide that oxygen that's otherwise not getting to fish because of fine sediment. So just because a brook trout is actually in a stream does not necessarily mean that stream has really good water quality with respect to sediment. So I'd say in general, trout can tell us something about sediment, but aren't, a great indicator of high sediment loads all the time. There are ways for them to persist in high sediment areas. And the story is pretty much the same when it comes to increasing nutrient loads, which is another important water quality issue in New Jersey, and across the Northeast. In fact, in small increases in nutrients can actually, in theory, increase brook trout abundances because the increases in nutrients increases algae growth, which increases bug growth, which can increase fish growth. That's really a slippery slope, and we don't know where the threshold ends, where increases in nutrients beyond this threshold basically completely flips the system on its head. Algae can grow kind of out of control, which through different biological processes essentially leads to major declines in dissolved oxygen, killing off brook trout. So there's this kind of somewhat ambiguous relationship at times between nutrients and brook trout, although brook trout probably do better overall in low nutrient streams. They still can be found in places where nutrients do impair water quality. And finally, and I think less ambiguous, is what George was mentioning, is that brook trout, we know, are cold-blooded. Their body temperatures are essentially the same as their surrounding environments. And their biological performance is really driven by temperature. And brook trout are not just cold-blooded, they're also something called a stenotherm, which means they're essentially cold water specialists, especially compared to other New Jersey fish. So as we have any sort of thermal impairment or increases in our stream temperatures, we know that brook trout are going to respond negatively. There's not really any way around it. And so because brook trout are basically among our most sensitive fish species to increases in temperature, we can often use them as a biological indicator of thermal impairment. So if I don't see a fish in a stream, a wild brook trout in a stream, the first question I'm going to ask is, is there a temperature issue? So really, what I think, and what we're going to continue talking about in this presentation, is that what trout tell us most about water quality is how our temperatures in that stream, is that stream thermally impaired? So if a stream is not thermally impaired, we can then start asking questions about how sediment or nutrients might be impacting brook trout. But if the stream is thermally impaired, which is often the case, our final step is to then go out and ask what's actually driving that thermal stress and what can we do about it. So that's what I'm going to be talking about for some more of this presentation. So why are we talking about temperature? Again, I think it's going to be the most pressing threat to wild trout persistence in New Jersey and areas around New Jersey. And why might you want to learn more about temperature if you don't care that much about trout? I think first because there are many other impacts that temperature, thermal stress has on our streams. We'll mention those real quickly. I also think that many of the solutions that we take or kind of issues that we address to reduce temperature encompass pretty general approaches to river conservation and water quality improvements in general. So I think that although TU focuses on temperature and other organizations might focus on nutrients or sediment, I think many of the approaches that we take to kind of improve that water quality are one and the same. So we have win-win situations for both trout and trout fisheries as well as water quality. So I'm just going to step through each of these bullet points. So trout are really well studied because they're really a recreationally important species. So there's a lot of science out there that allows us to essentially build a trout thermometer. So basically, how do trout respond to different species? So for example, we know that the optimal growth for brook trout is when a stream is 58 degrees. Brown trout, it's actually pretty close to the same, maybe just a little bit higher, although a brown trout is more competitive, as George mentioned. So they can outcompete brook trout, for these different thermally suitable spots in a stream. At 65 degrees, we actually have baby trout stop growing. At 68 degrees, this is a really important number. This is when basically a trout's body starts exhibiting heat stress kind of at the cellular level. This is a really good time we suggest people stop fishing. When you hook a fish at 68 degrees or above, not only is that fish fighting you, but that fish is also now fighting heat. That generally is a bad combination. And if you're a catch and release angler, the chances of that fish actually surviving after you release it are much lower when you have higher temps. And if you're a catch and keep angler, which many people are, this is also a time at which fish behavior switches from thinking about food, thinking about basically nothing else except growing, to thinking a lot more about surviving thermal stress. So it might also be a time when fish are just kind of slowing down. So even if you're a catch and keep angler, it might be a good time to stop. This next metric, 74 degrees, if you think about the hottest week of the year in a trout stream, that's what this number is referring to. So if the hottest week of the year is above 74 degrees on average in a stream, that's when many different studies show that you're just not going to find wild fish if you get that hot in a stream. So that's an important number for us when thinking about conservation and finding populations, maybe reintroducing populations of wild fish. And finally, even at short exposures, temperatures above 80 degrees are often lethal to many of the fish that are exposed to that. So I kind of wish we had like a way to take a poll, but what I'm going to do is show you where the average New Jersey trout production streams, so this is places where trout we know actually reproducing, where you think it lines up on this trout thermometer. So in 2018, the Bureau of Freshwater Fisheries monitored temperatures at 44, I think, different trout streams in the state of New Jersey. And they basically calculate a number that's very comparable to this red number, 74 degrees. So that temperature, the average temperature of those trout streams is actually 70 degrees Fahrenheit. And so this is relatively hot. If you can see your 18 degree, or sorry, 20, I can't do math right now, 12 degrees above what the best growth temperatures are for trout. And you're really getting close to that 74-degree threshold where wild trout can just no longer persist in our streams. So temperature stress and is definitely an issue that's limiting the distribution of our wild fish. And that's not just here, but that's across kind of across the entire range of brook trout. So what I'm showing here now is information from the Eastern Brook Trout Joint Venture. So this is this collaboration of state and federal scientists, of nonprofit groups, some academic scientists, who in 2005 got together to kind of assess the current status and the future threats to brook trout across its entire range, from Georgia up to Maine. And so what I'm just showing you here is kind of expert opinion, at least in 2005, from state agencies. What were the major threats or the major stressors to wild brook trout in each of these states? And what you can see is that high water temperature is kind of the most widespread or second most widespread threat across all of our neighboring states. New Jersey put it fourth on the list. However, I'd say first that urbanization and dam inundation, which actually rank up above it for New Jersey, are both major sources of thermal pollution. So they kind of go hand in hand. And also, this is about 7 years before the Bureau of Freshwater Fisheries in New Jersey actually started measuring continuous stream temperatures in earnest and relating that to brook trout abundances and brook trout occupancy. So I'd guess that if you talk to some people at the Bureau of Freshwater Fisheries, they might rank out this temperature as a more important issue as well, kind of ranking along the same lines as our neighboring states. That's certainly not to say it's the only issue. As you can see, non-native fish, so brown trout competition, dams, just sedimentation are certainly issues as well, but temperature is one we think about most often. And so this isn't just an issue that's happening right now, it is going to continue happening at the same level. And we know that climate change is going to exacerbate this problem for wild trout. So what I want to show you is this map that's generated by the Us Geological Survey. So this is a federal agency that basically takes information on land cover. So things like, is a watershed forested versus is it urbanized or is it agricultural? The slope of the mountains where the stream is flowing down, the temperature of those streams. So they create a temperature model to predict where brook trout currently are. And they're not just doing this for New Jersey, they're doing this across their range. And so what the output of that model is basically different colors here. So the blue colors are where we think brook trout, wild brook trout, have a high probability of being right now today. So you see the Flat Brook, Quantic, and maybe Upper Passaic, Raritan headwaters, parts of the Muskie. And so this model is tested against state level data to show it does a decent job at least. And so once we have a model doing a decent job, what we can do is predict what this map might look like and what wild trout might look like in New Jersey in the future as we increase temperatures. And so basically all the USGS does to make these predictions is just to change stream temperature, assuming that there's gonna be a 2 degrees Celsius increase in air temperature. So that's a scenario that's, I think, in New Jersey, probably like 2050 or so, at least currently predicted. And what you can see is that the blues are pretty strongly reduced. Essentially what these models are telling us, what the science is telling us, what our own data are telling us is that it's really hot right now in New Jersey for wild trout, and it's probably going to get hotter, which is not exactly great for either our wild trout populations, our wild trout fisheries, moving forward. But this is not just an issue for wild trout. I also want to talk just for 1 second about why temperatures matter for stocked fish as well. So here I'm showing you just some data from Lepacon Creek. So this is Juniper monitors temperatures in the middle of Lepacon Creek, where this fish at this, this stream at this section of it is mainly a stocked rainbow trout fishery, at least in the middle reaches of Lepacon. So the black line is essentially the average daily temperature in the stream. And you can see we go from April to almost September 1st. And so what I've drawn here is this dotted line at 68 degrees. If you look back to our trout thermometer, this is essentially the temperature at which we said that trout start exhibiting thermal stress, and two, the time at which we suggested might be a good time to stop fishing. So those are two really important numbers for stocked trout fisher or anglers. First, because if you are recommended to stop fishing above 68 degrees, then if we're just assuming that if the daily temperature is above 68 degrees, you're not going to fish. So one thing we could calculate from this sort of information is how many days of fishing are available on this stream, at least this past year. So we're going to do that in a second. And the second thing that we can calculate is that for every day that that the temperature is above 68 degrees, depending on how far above 68 degrees it gets, we can actually calculate what's the probability that fish actually survive that day. So at 68 degrees, fish might be stressed, but they still have a pretty high chance of survival. But if we start approaching 75 and 80 degrees, as some of the hottest days here get almost, we can actually ramp up the rates of mortality for those stocked fish. So at the end of this kind of thought exercise, we can calculate both how many days an angler has to fish in this creek and also how many fish are left. So if we assume that 1,000 fish were stocked or so, how many fish are left at different periods throughout the potential fishing period. So I think those are two really good, interesting, and important numbers when thinking about recreational opportunities moving into the future. So when we actually do kind of these back of the envelope calculations for this year, 2020, based on this black line, what we calculate is that there's probably 63 days that were available to fish this year between April 1st and September 1st. By June 24th, less than 50% of the fish that may have been stocked, say April 1st, are actually surviving in this stream, in this model stream. And there's also, importantly, no fish that can actually survive, at least based on temperature, through the entire summer. So for those of you not really familiar with trout fishing, one cool thing about some stocked trout fisheries is that fish can actually hold over or survive for multiple seasons. Those are fish that generally become more wary and also can grow larger through time, and they become kind of a more prized kind of catch for anglers if you can get them. So it's pretty fun to fish in a place that does have holdover fish, but at least this past year, Lepacon didn't have that. So as you can see, I actually put in parentheses that this was a warm year relative to most of the recent, past 30 years at least in New Jersey. So to think about how climate change is actually impacting our fishing opportunities, we can kind of repeat the same process by actually ramping down the temperatures in the stream to match both an average year and a cold year. And so we do that with just relating some of these temperatures to past climate data. But again, the numbers are basically going to be the same that we're comparing. So if we ramp down temperatures a little bit to better represent an average year, we can actually see that in this stream we might have 80 fishing days. We have another month of more than 50% of our fish actually around to still catch. And we start to get some holdover fish. And then finally, in a really cool year, so cooler than average year, at least since the past 30 years, we might actually have 110 days of available fishing on Lepacon Creek with a theoretical rate of 75% of fish actually being able to survive through the entire period. So this is just, I think, really emphasizes that temperature impairment, and especially with climate change, is not only going to impact our wild trout populations and our wild trout fisheries, of which we have 45 or so in the state, but we could probably redo these calculations for every stock trout stream in New Jersey, from the Musconetcong Kong to the Pollenskill to the Pequest to the Raritan parts of it, and up north. And we could find out that climate change is probably going to reduce the number of days that we can fish and the number of fish that we can fish for. So another important reason for us to be thinking about temperature and trout. So I also told you that even if you don't care about trout, you might want to care about temperature. And I'll just give you 3 quick reasons. One is that there are definitely other kind of stenotherms or thermally sensitive species in our New Jersey streams. So they include the slimy sculpin, which we often find in close association with brook trout, and also our dwarf wedge mussel, this federally endangered wedge mussel, which many people are interested in protecting. We're finding more and more research to show that these wedge mussels are actually really sensitive to increases in temperature, and they start getting thermally stressed at about the same temperature as brook trout, apparently, based on preliminary research. You might care about harmful cyanobacterial blooms. So this is a shot of Lake Hopatcong. So there are obviously many different aspects of water quality that kind of have to work together to form a cyanobacterial bloom. It's a pretty complex process, but temperature is one really important, component of that process. Basically increasing the frequency of cyanobacterial blooms in our larger lakes. And so, often those temperature impacts can come from, upstream, poor stormwater management that eventually increases the reservoir temperatures as well. So you start having things like, microcystis or certain cyanobacteria species doing better at higher temperatures than your native or your algae communities. And you might get more of these cyanobacterial blooms. And then finally, and one that's really interesting to me, is that increasing temperatures has actually been shown experimentally to increase nutrient loads in streams without actually adding any more nutrients in from the terrestrial environment. That's because increasing temperatures, essentially through physics, just increases rates of chemical and biological activity. And so that means the breakdown and reprocessing of certain forms of nutrients into more soluble forms that become available in the water column. So just by ramping up temperatures in streams, you can actually have increases in the rates of nutrient recycling through those stream systems. So these are some reasons why, if you don't care about trout, you should still maybe think about temperature. And finally, I mentioned that the solutions that we're thinking about, at least, to reducing temperatures and the drivers of those thermal stresses often encompass many of the same approaches that other partners are taking across New Jersey and across the Northeast to address general water quality issues. So we're not reinventing the wheel. And oftentimes we can probably come upon win-win situations for both reducing temperatures as well as reducing other water quality issues. So just to kind of give an example of that, this is kind of like my little concept map of how I think about temperature effects on our wild trout populations in New Jersey, and the different aspects of my job that at times relate to those temperature effects. So we might think about temperature in the context of climate change, of non-native species, of riparian buffers and stormwater management, of dams, and even things like groundwater policy and road infrastructure. So I'm sure that many of you on the call can kind of relate to at least certain aspects of this web, and you might relate for very different reasons than temperature. But again, we can find win-win scenarios where both temperature and nutrients or sediment are improved in streams through these approaches. And so I just want to give the kind of end of my time here 3 quick examples, if possible. Sorry, I'm going a little bit long, on how we think about temperatures and the drivers of those thermal stresses and maybe some solutions. So first I want to mention dams really quickly. There are many dams in New Jersey And I just want to emphasize up front that I'm well aware that there are many pros and many cons of dams. So there are many social and environmental benefits like recreational opportunities, flood regulation, power, sometimes property values and water supply. There's also social and ecological costs. And one of those is temperature. So you see it's just one on a large list of things to consider when you might start thinking about dam removal. But in certain situations, it might be an important one to think about. So oftentimes, people have a pretty clear idea of the fact that temperature or dams increase temperatures. However, we don't actually have that much data available to really show what dams do to temps. So in big dams, especially out west, bottom release dams, we know they actually cool temperatures down. But on these smaller dams that we have in New Jersey and elsewhere across the Northeast, we don't have that much data to say what the consensus is. So what I want to plot here is just some data from kind of a similar setting in kind of Western Mass, and where each of these abbreviations on the bottom is a single dam. That dam is going to be represented by a bar, and the height of that bar is going to tell us, how much water temperatures changed from upstream to downstream of that dam. So if you have numbers right around, or bars right around 0, that means that the dam doesn't really impact water temperatures that much relative to the temperatures upstream. If you have negative numbers, that dam is actually cooling the stream. If you have positive numbers, it means the dam is increasing stream temperatures. And so what you can see is that there's actually a pretty interesting distribution. At least a third of our dams are really not impacting stream temperatures at all. 2 of them, at least in this study, are actually decreasing stream temperatures downstream. But there are, a significant number that are in fact increasing stream temperatures. So the takeaway message is that not all dams impact stream temps, but there are some that impact it a lot. So as you can see, this is an average temperature in August. 10.5 degree increase downstream is a pretty large number. So I want to give you an example from New Jersey about how we're thinking about dams and temperatures. This is coming from the Flat Brook up in the northern portion of the state. So the Flat Brook, throughout its length, is a stocked rainbow trout fishery. However, in the Big Flat Brook, a pretty long stretch of it, it's actually a wild brook trout fishery as well. So we know that wild brook trout do persist in this main stem of the Big Flat Brook. However, recent state data shows that these fish are actually in decline. And so one thing that TU is trying to do is think about, why are they in decline and how can we potentially bolster those populations? And so when we think about kind of a main stem wild brook trout population like this, and think about restoring it, the first place we often look is to tributaries. So tributaries for these sorts of fish essentially are fish factories. So wild trout adults move up into these smaller tributaries to lay their eggs in the fall. Those eggs have a nice safe place to overwinter. They hatch out in spring, and those juveniles actually live in these small streams throughout the early summer period, at least through most of the summer period. Because there's not much predation here. There's generally good habitat for these fish and plenty of food. So this is just one video of one of these tributaries where you do see a good number of wild young of year brook trout. So these fish that have these vertical stripes called par marks, they have these white fin tips. And these are brook trout, along with a bunch of other species, black-nosed bass, and I think white sucker, and probably some shiner and chub species as well. So some of these tributaries to the Big Flat Brook, there are about 13 in all, do look like this and do have good young of year populations. However, a lot of them don't, based on state data. And so the question is, why don't they? So all of these tributaries, or almost all of them, are draining state lands that are highly forested. So there's not really, a bunch of development associated with them. Even if you look into the past, many of them are in steeper slopes. They weren't all agricultural streams in the past. So they've had forest for a good number of years. But what you can plot is the dams that are on these tributaries. And 9 out of 13 of these tribs to the Big Flat Brook actually do have dams on them. So on one hand, those dams could just be blocking habitat upstream. That could be, better nursery habitat to increase the abundance of young fish that hopefully eventually move out to the main stem to become big fish. Or there could be thermal impacts in these tributaries from these dams as well. So that's what we're setting out to do, is to really find out if that's the case before we start making any additional plans. And so to do that, what we do is measure temperatures at these places where you see white circles, above, below, and then really far below this stream, kind of right where the stream meets the Big Flat Brook. And so what I'm gonna do is just show you what the average summer temperatures were at these different spots. So if you remember from that trout thermometer that we had, essentially above the dam, we have prime temperatures for growing young brook trout, pretty close to that 58 degrees. Below that, the dam basically is uninhabitable for wild fish, and really far downstream, the average temperatures are essentially right at that thermally stressful mark for trout. So the average temperature in the summer basically is a thermally stressful condition. So at least this one particular dam is certainly impacting temperatures in the system in a pretty negative way. You can do some more math and essentially figure out that this red dotted line, young fish really can't survive in the summer upstream of this red dotted line because of the thermal impacts of this dam. So what we've done is taken a 1.5 mile long, small tributary that's the perfect temperature for young brook trout growth, and kind of reduced it down to about a 1/4 mile stream whose temperatures are basically chronically stressful for wild fish. So no, the jury's still out for the rest of the dams in the system. We're monitoring it. This is just one way that dams might have an impact on thermal conditions for our wild trout populations, which eventually impact our wild trout fisheries in the Big Flat Brook. We can also think about riparian buffers. So these forested buffer strips that you see in the picture on your right, that was a riparian buffer here, kind of next to farmland. So you'd imagine in the past, essentially forest covered this whole area, but now in New Jersey and elsewhere, we need to protect these riparian buffers because we know they have many benefits and kind of serve literally as a buffer between more developed land and the water body itself. So buffers can reduce non-point pollution, reduce rates of overland flow, which kind of reduces peak floods, provides inputs into streams for macroinvertebrates and fish. And one of these things that buffers can potentially do is reduce temperatures through shading. However, in New Jersey, at least the Delaware portion of New Jersey, we've lost about 55% of our natural riparian buffers in this area, at least according to this 2018 study. So this is what some kind of denuded riparian buffers look like. I'm sure you've seen plenty of examples like this. And to just give you one example, again, from the Flat Brook system, this is from the Little Flat Brook, of what kind of these denuded buffers, potentially due to stream temps. I just want to show you some more example data that we've been collecting. So I wanted to show a cartoon rather than the actual landowner's property, just to keep that private. But the dark areas you can imagine are forest cover. The light areas are actually pasture for cattle. They graze right up to the stream. There's basically no trees. And so we, again, put temperature loggers on the upstream side, on the right-hand side, and the downstream side of this, almost mile-long stretch of stream. And so when you calculate the average temperature across the summer, it's again, in just a mile, you can increase the average temperature about 1.8 degrees, which is actually a lot in the grand scheme of the biology of trout. You can see that these temperatures already are really thermally stressful. There's lots of thermal impacts in the system, but this just provides an example of how riparian buffers are probably important for at least maintaining temperatures and potentially reducing temperatures, and not having them can increase temperatures pretty quickly. So what we can do is potentially replant these types of places. And so replanting buffers requires both patience. You can imagine that it might take a long time for these trees to actually grow to shade the stream, and it requires planning. So we actually know that small tributaries, for planting a much smaller riparian buffer, at least in terms of length, you can actually prevent warming kind of more efficiently than if you're trying to plant large streams. So headwaters might be a good place to start with these riparian buffer plantings. Again, if your goal is to reduce temperatures. So we're trying to start to think through these sorts of processes with partners. So what can you do with respect to buffers? You can go find some watershed groups to volunteer with. Plenty of TU chapters are planting buffers. Organizations like the Nature Conservancy, Audubon, Muscatine Watershed Association. Those are some that I work with in the Delaware watershed. I'm sure there are many people across the state doing this sorts of work. You can also talk to these groups if you own land along a stream and want to think about how you can improve your riparian area for trout and for water quality at the same time. And finally, I want to talk just a little bit about groundwater as this kind of source of thermal refuge for fish. So the past two examples are basically, we're talking about how to remedy thermal stress. We want to talk about how, and on a high note, and think about how temperatures might be doing better than we imagine in New Jersey. So this is kind of a schematic of how groundwater works in the water cycle. You can imagine that rain falls in this forested area in the middle of the picture. Some of that rain runs down to the stream through overland flow, but some of it percolates back down through the water table to the water table following these blue lines. This becomes groundwater. It stays in that system for days to many years, depending on the geology. And eventually some of it comes back up to the stream and discharges to the stream. So a really cool feature of this groundwater is that it kind of stays more similar to the temperature of the earth than it does to the temperature of the surrounding air. It's much more thermally stable throughout the year. What that means is that groundwater is cold relative to surface waters in the summertime and warm in the wintertime. So this can basically provide thermal refuge for trout and other thermally sensitive species and processes in multiple seasons. So again, I'm gonna give you a quick example from northern New Hampshire. This is from some of my graduate work where we know where brook trout were spawning. And we wanted to know if those places were associated with groundwater. So we create these temperature maps. So basically every 1 meter in the stream bed, we stick a thermometer and see what the temperature of that stream bed is. So I'm gonna show you a map, kind of looking from above down in the stream bed. The areas in lighter blue are going to be colder. They represent groundwater coming up into the stream bed. The areas in red are going to be warmer and they represent surface waters. So what you can see is that there's some pretty big thermal diversity in just a pretty short stretch of stream. This is probably about 20 meters or 30 meters long. And you can see that this blue temp where groundwater is coming up into the stream bed is actually 22 degrees colder than the surrounding surface water. So this just provides kind of a visual example of how cold groundwater can be compared to surface waters and how it can be a great resource and refuge for thermally stressed trout in the summertime. And then you see the kind of black crosses. We actually go back in the fall and find out where brook trout actually build their nests. And it also happens to be right in these places where groundwater is coming up into the stream bed. And that's because, we think it's because brook trout, eggs incubating at warmer temperatures in the wintertime have higher survival rates. At least that's the thought. And so now I want to show you an example of the benefits of groundwater to our trout from New Jersey. So this is Juniper's Lapacon Creek. We talked about this before. It's both a stocked and a wild trout stream. In headwaters, we have wild brook trout. Down below, we're thought to have wild browns. But in the past several years, state data show that the brown trout population in the lower Lepakong and middle Lepakong is declining. Juniper's temperature data that she's been collecting has showed us that, the middle Lepakong is actually just really too hot for trout. It goes above that 74-degree threshold that we mentioned. But Juniper and the Musconetcong Watershed Association, suggest that we look at temperatures downstream, closer to the town of Phillipsburg. So we actually did that. So we took this kind of longitudinal temperature survey on the hottest day of the year. And so each of these white dots is where I'm going to show you a temperature measurement we took. And this is in the main stem of the surface water of the stream. And this is, about a mile-long section of stream that I'm showing you here. And so what we found is pretty incredible. So up in the kind of middle sections of the stream to your right, so the water is moving from right to left. Temperatures on this hot day of the year are almost 82 degrees. So this is definitely, essentially deadly for trout. But pretty quickly across the, through the stream length, we start to see major declines in temperature. So that once we get, a mile downstream from our first sampling point, we're actually down to entire stream temperatures. This is not just the stream bed temperature. The entire stream temperature is down to about 61 degrees Fahrenheit. And, relative to that trout thermometer that I showed you earlier, might imagine this is a huge difference. What it means and what we found is that wild trout actually are surviving down here and doing pretty well. Whereas we're not finding any wild fish or stocked fish at this point, up in the far right of this image. So what we're doing next is we're doing a restoration in this area right here. So this is, floodplain reconnectivity work. This is excavating deeper pools. This is installing some wood. And we hope that not only are improving trout habitat, but we're also improving those connections between groundwaters and surface waters, and maybe, incrementally moving cool temperatures further and further upstream in the system. And finally, we've also identified, through the survey, this barrier. It's kind of an old log dam that probably prevents wild fish from moving between these cool places and these warmer places. And in the middle of summer, a trout might not want to swim upstream to these warmer places, but in shoulder seasons like the spring and the fall, upstream is perfectly good habitat, and at that point thermally suitable to go feed, to potentially spawn in the wintertime. So I think there are many opportunities for us to restore and improve the wild trout fishery as well as the stock trout fishery on Lepakong Creek. But it really all starts with groundwater, providing sort of this climate resilience in the system. And this is probably not the only system like this in New Jersey. We know that New Jersey is full of karst geology or carbonate rock, where groundwater and surface waters tend to often interact. So this same sort of scenario likely exists in our other New Jersey streams, at least in some of them, but we just really haven't found it yet. So this is just a quick video of actually wild brown trout in the Lepakong through this lower reach. It's kind of hard to see, but if you look to your upper right, you actually see a lot of young fish. You just saw a much larger adult fish swim through the picture. You'll see a couple different fish swim in and out of different sizes. So these different size classes in a wild fishery really suggests that this population is doing well, despite water quality issues that we know about in the Lepakong, like increased sediment loads and some nutrient problems. So, if you have the right water temperatures, you're probably going to have a brook trout or a brown trout wild population, and then we can move forward and fix other water quality issues as well. So what can you do, or what can we do? First, you can kind of reach out to different watershed groups to think about how to measure temperatures and streams. There's lots of different ways that we're using temperature information to try to find cold places for trout to live into the future. You can also start doing some reading, reach out to your watershed groups who are doing groundwater policy related work. So there's many different ways that we use groundwater. We extract it, obviously for our wells. We actually can put sewage back into our groundwater through different discharges. And so there's some issues right now in New Jersey about how and when should we be protecting groundwater at the same standard as our surface waters. And so that definitely comes into play when we think about trout and water quality and trout persistence into the future. So to recap, I hope the main take home you get is that improving water quality improves trout populations and vice versa. Improving trout and trout fishing definitely incentivizes improving water quality, so that we can get win-win scenarios across the board. So sorry that ran a little bit long, but I'm happy to take any questions if there are any.
Thank you so much, Keith. That was outstanding. It was very informative. I really appreciate you taking the time to give us such a thorough presentation. We do have a few questions. I actually have a bunch of questions I wrote down myself, but I can ask you those offline. We have a few questions from the audience. Zach is feeding them to me in a separate document. So anyone who has any questions, please put them in the Q&A. We'll try to get to a few of these. We're a little bit over on time, but let's try to give 15 minutes to questions. We'll go to 8:45. So here we go. Temperature change also impacts the time that the hatches occur in different areas. Can you elaborate on what impact that might have for fish populations?
Yeah, so I think that's a great point. So macroinvertebrates essentially live in the stream for different amounts of time during their life. Just kind of summarizing, people don't know, and some then actually basically move into a terrestrial form where they're hatching, and so fish are eating both these forms within the water and as well as those that hatch. And so if you have fish hatching, macroinvertebrates hatching at different times, that definitely can impact trout populations. Especially, I'm thinking of young of year fish. So young of year fish are hatching at very specific times in the year, and that's often thought of to both avoid harsh winter conditions, but also kind of hit the timing of bug production just right. So if you have basically changing timing of bug production, but you don't change your timing of young of year hatch, you basically could have a lot of young fish starving and not surviving very well. Vice versa, water temperature change might impact when fish are hatching and kind of put them at a time period that's after or before when best bug production is happening. So I think a lot about baby fish, and that's, I think, a really clear way that temperature changes are probably also impacting fish populations.
All right, great. We'll move on to the next question. All right. Sarah and Tim say they caught a brown trout today at the South Branch of the Raritan and have caught some beautiful, large, and colorful holdover browns on Powhatan Creek, 21 inches. But they want to know, it's a two-part question. One, can brown trout hold over at higher rates than rainbows under these increasingly hot summers? And two, do you know if there are any plans to start restocking browns?
Juniper, I think I could take a shot at least part of that. I think there are two objectives that have to be met before it's physically going to be possible to start restocking browns or even brookies. And that is, at the Peak Quest hatchery, there is a long running or long planned project to put covers over the hatchery raceways to prevent the birds from coming in and infecting whatever fish are in them. So the construction of those raceways, which I believe may even incorporate some kind of solar panel, is part A. Part B is that the state is still looking for fish that are more disease resistant than the brown trout and the brookies that were destroyed in 2014. So I would say that the answer to the second part of the question is yes, the state has indicated and are making moves in the direction of restocking brown trout, but I don't know when that might happen. The first part as to whether brown trout hold over better than rainbows, I don't know the answer to that. I would say, knowing that they are probably the strongest predator, they might be inclined to sustain themselves in worse conditions. but Keith might be better able to answer that than I am.
So I'd say that I really don't know, and I wouldn't venture a really great educated guess. They have pretty similar thermal tolerances, so at least based on temperature, I wouldn't know the difference between either one holding over better. I would say I think I mentioned the Powhatan, and I would just shout out that just like the low pat and neighbor to its north, there's some suggestion that the Powhatan has a bunch of really good groundwater input to that system. So I think that could be also a really great wild trout fishery. I know there are many impacts to the Powhatan that need to be worked on, but I think the base is there. And that means the temperature, at least in some places, is there. So that's definitely a stream to look into the future.
Excellent. Okay, we have another great question. This revolves around the low pat. And I know I had mentioned earlier that a lot of the work we do revolves around restoring water quality in the low pat, but that the stream is under a great deal of development stress in the area. There are warehouses popping up in every corner. So this question is a good one. Is there any correlation with this temperature increase with the development going on in Phillipsburg and Lopatcong? So when you consider these large warehouse developments, do these construction sites and all of the impervious surface that they generate add to the temperature problem? That's my expanding on the question.
Yeah, so I'd say, first of all, in general, I'm sure the answer is going to be yes. I don't think we exactly have the data to show that right now. But we do already see, in one of our restoration sites, just below a warehouse, essentially, we see stormwater runoff that probably was not there before, and that will certainly lead to increases in the thermal spikes. Maybe not persistently, but certainly during storm events. And that's a whole other issue that we could talk about. Bureau of Freshwater Fisheries is interested in is how temperature spikes associated with stormwater, also negatively impact trout populations. So I think stormwater issues in Lopatcong probably exacerbate temperature concerns. We do have some indication and actually have some loggers that hopefully will show it, but that the very lower low pat, which has tremendous groundwater input, is generally very thermally stable and a great refuge, probably has stormwater impacts such that during a big thunderstorm in July, you actually get pretty big spikes in temperature, even in that really good groundwater influence section. So stormwater is certainly an important issue to be thinking about, even when you have great groundwater temps supporting stream on most days of the year.
Right, I agree. So we're going to wrap it up, but I just want, I want to add to that a little bit. Some of what we've experienced in Lopatcong with these massive construction sites is their failure to control their stormwater during construction. And the sites are so massive that we have one enormous site right on Route 22 near the Phillipsburg Mall, where they've constructed a massive set of warehouse buildings. And while they were building that, they were essentially sending, pure sludge into the stream over and over and over again over a period of years. So it becomes an ongoing issue. And if you're not actually looking for it, it goes unnoticed and it goes unaddressed. So we have a lot of very active residents in the area who live along Lock Street nearby that region. And they keep their eyes peeled on the stream. And when they see a problem, they let me know. And that's just, I think, an important point for us all to take away. Keep an eye on the stream. Another point that I've heard made about the value of fishermen and outdoorsmen, George, I think you might have said this in our last conversation, is that they're out there, they're boots on the ground, and they notice things, they see things. So it's really great to be engaged, whether you're, a resident or a recreational enthusiast. And I think that unless you guys want to add anything to that, I'm going to toss it back to Zach to close us out for the evening. But I want to thank Keith and George for really an outstanding set of presentations. It's been great. I want to thank everyone for sticking with us. Keep an eye out for the online video that we'll put up on Facebook as soon as we have it. And I hope to see you sometime soon. Come out and fish the low pat. Hook up with those Ridge and Valley chapter guys out here for Trout Unlimited. They're great.
How can I top that? Well done, Juniper. I'll just extend the coalition's gratitude to Juniper for playing host this evening as well. Thank you, Keith. Thank you, George. All registrants will receive an email with the recording when it's ready on our YouTube channel. So once again, thank you, and tight lines, everybody, tight lines.